Dear students, welcome to the Module 3 contents, that is the nucleation, plastic deformation and heat treatment. So nucleation and growth, here there are two states. One is the homogeneous nucleation and the other is the heterogeneous nucleation. So nucleation happens in metals and alloys. There are two mechanisms as I told you. So how to differentiate homogeneous and heterogeneous nucleation? So this type of nucleation happens when the new phase which is going to form uniformly throughout the parent phase. Whereas heterogeneous type is, it will be some of the disorders which will be present in the structure. So structural inhomogeneities are there, which will be contained, it should be on the surface, insoluble impurities, grain boundaries and dislocations. So in the homogeneous nucleation, you are going to calculate by taking the free energy equation. So if it is a spherical particle, we can take delta F 4 by 3 pi r cube into delta G into 4 pi r square into nu, where delta G is the Gibbs free energy change per unit volume, where gamma is the surface energy per unit volume. So if you substitute in the free energy change equation, you will be able to get the value. Based on the value obtained, we can tell the nucleation whether it is homogeneous or heterogeneous nucleation. So at the maximum variation, where R is the surface energy and the volume free energy exactly balance each other. So thereafter the variations in the volume term becomes dominant, and as this term is negative, there is a continuous decrease of the energy system. So like this, based on the inputs what all we get for the delta G, gamma and R, these three parameters helps to define the homogeneous nucleation. So by setting df by dr is equal to 0 in the above expression, so the curves are obtained for the volume free energy and the surface free energy contribution. So the total free energy change attending the formation of spherical embryo nucleus during solidification. So here delta F and the critical nucleus radius are indicated by R. So here R is equal to minus 2 nu by delta G. Delta F is equal to 16 by 3 pi R cube into delta Gs. So in the graph you can see the corresponding output, the free energy change. When the particles are smaller than the critical size are called as embryos. So here larger than if the particle size is larger than the critical size, then they are called as nuclei. So critical size particle is a critical nucleus. So delta G becomes more negative with the lowering of the temperature. So the critical condition occurs at smaller value of F and R. So if you substitute the expressions, you'll be able to know what exactly the changes are going to happen. So here the graph indicates the free energy available delta F in the figure B. In the figure A, you can see 4 pi r square and 4 by 3 pi r cube into delta G with respect to radius. If you plot, it is balanced on both the sides. So if there is the change in energy with respect to radius here, in the second graph we'll be able to exhibit. So if it is heterogeneous equation, how it behaves? So in the heterogeneous nucleation, here we can observe that the energy distribution, when you take it with respect to 3 axes. So here the nucleation at the preferred side in the assembly is greater than at the other side. During solidification of a liquid, inclusion of particles in the liquids and the wall of the container holding the liquid provided preferred nucleation sites. In solid transformation, foreign nucleation grain boundaries interface, staking faults, dislocations provide sites for preferred nucleation. So if you consider nucleation of beta from alpha, here on the planar surface of a foreign inclusion, here it shows. So here beta nucleates on the surface. So here the surface which is tangential to the gamma, alpha and beta, it goes beyond the range of beta. So both beta and delta, it is in the two different layers. So beta particles form a shape of half lengths on the delta surface. To calculate the nucleation kinematics, we have to assume surface tension forces at point O are in equilibrium. So with respect to equilibrium, all other forces are considered in the 3 directions. So where delta theta is the angle of contact, where gamma alpha delta is equal to gamma alpha beta into cos theta plus gamma beta delta, that is the volume energy and the free surface energy. So if you take delta F heterogeneous, if you substitute in the above equation, you will be able to get the expression for critical free energy in case of heterogeneous nucleation. So by using both the equation for homogeneous and heterogeneous equations, you will be able to tell the free energy available in case of homogeneous nucleation and heterogeneous nucleation. In case of plastic slipping, here you can see there may be atoms partially at one side and the other side also. So where all the dislocation of the atoms occurs with respect to the slip plane. So the slip plane indicates that atoms are going to get changed from the above position. First phase you can see the atoms are aligned in the same direction, the vertical direction. So whenever the slip plane comes, so atoms in the given position there, it won't be available from the slip plane. So after the slip plane, sometimes it is available. So there will be a dislocation or change in the positions of atom, so that slip is going to happen. So if you take edge dislocation, here you can see in the figure what we show is that in the 3D. So here extra half plane of the atom is available. So edge dislocation, it is going to happen with respect to surface. So direction of dislocation motion, edge dislocation, you'll be giving a extra half plane of the atom on the surface. So like this, edge dislocation is present. So if you take plastic deformation by twinning, here you can see the existing plane atoms where it is shown in the dotted form. So when you add load on the surface, the atoms from the one plane, it gets shifted to the new plane. At last, the original lattice position, it will be going to the new position. So that if you take side A, it is perfect region, side B, it is the new position by having the twin zone or deform zone. So like this, the plastic deformation by tuning, it is going to occur.